Okay, and just like as always, if you have questions as I'm going through this, just interrupt me. Okay. Let's make this full screen. Okay, so now we know everything we need to know to graph this. You need to know holes, and you need to be able to find asymptotes. And the x-intercept is the one thing that is kind of new. The x-intercept, you just set the numerator equal to 0, and you'll find the x-intercept. So let's look at this one right here. We have this. Oh, I want to move this somewhere. X squared. Oh, I can push hide. Yeah. No. X squared minus 3x plus 2 divided by negative 2x squared minus 6x plus 8. Now, the first thing I'm going to do is simplify this function, and I'm going to factor everything. Now, some teachers have like differing ways of doing this. I always like to check for holes first versus last. Some people will say check for them last. It really doesn't matter. So I want to check for them first, and I'm going to do that by factoring this. So I can factor the top to be x minus 2 and x minus 1. The bottom, I'm going to factor out a negative 2 first. So I'm left with x squared plus 3x minus 4. Now I can factor that bottom further to be x plus 4 and x minus 1. Okay. And from doing that, I can see that, oh, this x minus 1 right there is going to cancel, which means we are going to have a hole at x minus 1. This is why I find the holes first. I think it makes more sense to find them at the beginning, because you'll, right from the get-go, you'll see if something can cancel. Okay, so that means the hole is at x minus 1 equals 0, so the hole's at x equals 1. Okay. Now we have to find the y-coordinate to that hole. So I'm just going to cancel these, and we're left with x minus 2 over negative 2 and x plus 4. And I'm going to plug in 1 to this equation here. So f of 1 is going to be 1 minus 2 over negative 2 times 1 plus 4. Well, 1 minus 2 is negative 1, and then 1 plus 4 is 5, so that's going to be negative 1 over negative 10, which is 1/10. Okay, so that means I have a hole at 1, 1/10. Okay, and a hole is just a break in the graph. So if I go over to our graph over here at 1, 1/10, that's about right there. I'm just going to put a hole right there. Okay, and I drew mine in red. It doesn't have to necessarily be a certain color, just an open circle denotes a hole. Okay. Any questions with holes or finding this hole? Okay, so once you find the hole, then we're going to find the x-intercept. So to find the x-intercept, that's where I set the numerator of our simplified equation equal to 0. So I'm going to set x minus 2 equal to 0, which means that x equals 2. So that means that this function crosses the x-axis at 2, 0. So then again, I'm going to go over to 2, 0, and this time I'm going to draw a filled in circle right there. Okay. Open means it's like there's not a point. Filled in means there's actually a point. Okay. And then I'm going to find my vertical asymptote. Vertical asymptote you find by setting the denominator equal to 0. And it has to be of your simplified equation. So I'm going to set that x plus 4 equal to 0, because negative 2 is never going to equal 0, which means that x equals negative 4. So we have a vertical asymptote at x equals negative 4. And I'm going to go over to negative 4 and just draw a dotted line right there. Okay, the dotted line denotes that it's an asymptote, that nothing can hit that asymptote. Okay. And then horizontal asymptote, we have to use these rules. And it doesn't matter if we use this equation or if we use this equation. Okay, because I didn't write it, but in this equation, they're both first degrees. In this equation, they're both second degrees. So no matter which one we look at, they're going to be the same degree. And then we just look at leading coefficients. So we could either look here, it'd be 1 over negative 2, Or we could look here, it'd still be 1 over negative 2. You will always get the same thing. Doesn't matter if you look at the beginning equation or your simplified equation. So then it's, if they equal each other, you look at the ratio of the leading coefficients. So that's going to be 1 over negative 2, which is negative 1/2. So our horizontal asymptote is at y equals negative 1/2. So then I'm just going to go down to 1/2 right here and draw that horizontal asymptote. Okay. And then I can kind of guess like where I think this graph is going to look. Like I would guess, since these 2 points are above this asymptote right here, that this side's going to look like this and this side's going to look like this. Okay, but let's double check, because there's sometimes they might both be here or something weird could be going on. So that's where you need to draw a number line, and you put whatever like is crossing the x-axis. So I'm going to put my x-intercept of 2, and I'm going to put my vertical asymptote of negative 4. And then we're just going to plug numbers in. So I'm going to plug in like a negative 5 and a 0 and then a 3 to see where it's positive and to see where it's negative, so that I know for sure how to draw this graph. So if I do f of negative 5, and I'm just plugging it into the simplified equation, it doesn't really matter. But so that's negative 5 minus 2, and then negative 2, negative 1 plus 4, you get a negative 7/2. Okay. So then that means this part is negative over here. If I plug in 0, anytime I can plug in 0, plug it in, because 0 is your easiest. And I literally, like, you could go through all the steps of doing this, or you could take this right here and plug it into your calculator, just how that looks. And you end up getting 1/4, which is positive. So that means this part, until we get to that, is positive. And then if I plugged in 3, so like past the x-intercept right there, I get a negative 1/14, so that's going to be negative. And I could have plugged in a 4 here. I could have plugged in 1. I could have plugged in like negative 6. It just has to be some number like less than this, some number between it, some number greater than this. And then to graph these, question, is there a question?
No question. What if you don't have like an x-intercept?
Then there's just no x-intercept. Then you would just use your like vertical asymptote for
Okay,
the line. Any other questions?
Yeah, how did you find the x-intercept again?
So I simplified it down to this, and then you take your numerator and set it equal to 0. So I set the x minus 2 equal to 0, and that's where I got the x equals 2.
Okay, and now you're just like plugging numbers into it to see where the graph is?
Yeah, to see what the graph is going to look like. So I could see, like, here, I'll just click through this. So I can see over here that this is negative, because less than negative 4 is negative. So that means this all has to be below the x-axis. Between negative 4 and 2 is positive, so this part has to be above the x-axis. And then above negative 2 goes back negative, but it follows this asymptote, so it's just going to be barely below that x-axis right there. Okay. Questions with that? Okay, I don't think I made you find the domain and range, and you're not going to have to for the test, but let's just do it anyways. So the domain here, remember, domain's your x values. So it's going to be negative infinity to negative 4, because it's going to stop at that asymptote. Then it's going to be negative 4 to 1, because of that hole right there. There's not going to be a point at 1, and then 1 to infinity, because it's going to go towards the positive x's forever. And then same with the range. It's going to be negative infinity to negative 1/2, because of our horizontal asymptote. And then negative 1/2 to 1/10, again, because of the hole, and then 1/10 to infinity. Okay, questions with that one? Okay, let's do this one. So x squared minus 9 over negative 2x minus 2. Always, always factor it first. Okay, so that top factors, that's the difference of squares. It factors to x minus 3 and x plus 3. The bottom I can pull out a negative 2, and I'm just left with x plus 1. Now here there's no hole because nothing cancels, so there's just no holes. Now in this one, there's going to be 2 x-intercepts because we have 2 different factors up on the top. So for our x-intercepts, I'm going to set the x minus 3 equal to 0 from here. And I'm going to set the x plus 3 equal to 0 from right here. So that means that x equals 3 and x equals negative 3. So we have 2 x-intercepts. It's possible to have like a ton. You could have infinitely many x-intercepts. I would never give you, I don't think I ever give you more than 2. But so our 2 x-intercepts are 3, 0 and negative 3, 0. Okay. And then we can just graph those. So 3, 0, that's right there, negative 3, 0 right there. And I always just graph things right as I find them. I found that that's the easiest way instead of like finding everything and then graphing at the end. Okay, vertical asymptote. That's where you set the denominator equal to 0. So negative 2 is never going to equal 0. I don't have to worry about that, but x plus 1 can equal 0. So I'm going to set x plus 1 equal to 0, which means x equals negative 1. So we have a vertical asymptote at x equals negative 1. So if I go to negative 1 right here, I can just draw that vertical asymptote. Okay. And then horizontal asymptote, that's where we have to look at degrees. And I'm going to look back right here since this is like factored and nothing canceled. So if we look here, it's a second degree on top and it's a first degree on bottom. So that means that P is greater than Q, which means there is no horizontal asymptote, but there is a slant asymptote. Okay, is there any questions with that piece or anything to that point? Okay, and then remember when we find slant asymptotes, you have to use long division. So we're going to take that x squared, and I put a 0x in as a filler, minus 9, divide it by negative 2x minus 2. And I'm going to take x squared, divide it by negative 2x. X's cancel, I get x over negative 2, which is the same as negative 1/2 x. So I'm just going to put that 1/2 x on top. Negative 1/2 x. Multiply negative 1/2 x times negative 2x is x squared. Negative 1/2 x times negative 2 is just x. Switch those signs. These ones cancel. Here I'm left with negative x, and then I'm going to bring down that 9. Then again, just divide first with first. So negative x divided by negative 2x. X's cancel, negatives cancel, so I'm just left with 1/2. So that's going to be plus 1/2. And then I could multiply this. I didn't because whatever we're left with is our remainder. And remember, you can always ignore the remainder. Okay, so once you get like your mx plus b, you're done. You don't even have to finish your long division problem because you can just ignore the remainder. Okay, is there any questions on finding the slant asymptote? Okay, and then we should know how to graph this. This is the y equals mx plus b. M is your slope, b is your y-intercept. So for this one, our y-intercept is at 1/2. Oh shoot, I might have done this wrong. Dang it, I did. Let's see, can I draw on this? So our y-intercept, so our y-intercept is at 1/2 right there. And then our slope is negative 1/2, so that means I go down 1/2. Down 1/2. And this right here would be, whoops, that's really bad. that would be our slant asymptote. So let's just pretend that I did this right. Okay, this was just supposed to be shifted up. So all of those are supposed to be shifted up. I did it at -1/2, but that would be right there. Just like shift all of that up. Okay, that's our slant asymptote if it was moved up. Are we okay with that?
Wait, I'm a little bit confused again. So, what did you mean by... Okay, wait. So, mx plus b and the slope, is it going up 1/2? Is that what we're doing?
Going down 1/2 here. Look, I'll just fix it while I'm on here. So this point was supposed to be up right here because you cross at 1/2. Okay. And so then if you go down 1/2, you guys are going to see how I make my videos, but down 1/2 because of this. So -1/2. So I go down 1/2. There's the second point. And then if I do that one more time, you could do it as many times if you want. But since this is negative, we're going down instead of up. So there is like 3 points. And once you get 3 points, it's easy to draw a line from that. So we can create our slant asymptote from there. Okay, so that's what our slant asymptote is supposed to look like. Sort of. Okay, are we okay with that? So if this is negative, it means you go down. If the slope is positive, you go up and over. But I always go, the negative will just tell you if you're going up or down. And then always go to the right. I always just go to the right. Okay, I don't ever go to the left. It makes it a little bit easier to just go to the right. Okay, are we okay with that? All right, let me present this again. So this is going to go back to my non-right one. But then if we plug in, we do our number line. And we're going to go from -3 because that's an x-intercept. And then -1 because that's the vertical asymptote. I don't care about this slant asymptote really, except for the fact that it's going to follow along it. And then +3. So then I can plug in, let's say like -4. If we plug in -4 to this equation, you get 7/6. So that means from this point right there, it's positive. If I plug in like -2 between these two, whoops, I'd get -5/2. So that means from here to here, that's going to be negative. And between these two would be like a 0. So if we plug in 0, you get +9/2. So from there to there is positive. And then bigger than 3 would be like 4. It is negative. So then the graph, and again, remember this was supposed to be up, but the graph looks like that. Okay, questions on any of that? Sorry for messing up that graph. Okay, and then the domain here would be -∞ to -1 because we have to stop at this asymptote. But then from -1 to infinity, since there's no holes. And the range, since we have a slant asymptote, the range is -∞ to +∞, because there's nowhere that it's just going to stop and like follow along some horizontal thing. This piece right here is still going up forever. This piece right here is still going down forever. You're going to hit every single y value along this graph. Okay. Questions on that? Okay, let's do one more. So if we have 4x minus 12 over x squared minus 4x plus 3, factor everything. So I'm going to factor out the 4 on top, and I get x minus 3. On the bottom, that factors to x minus 3 and x minus 1. So it looks like we have a hole here because these x minus 3s are on top and bottom. So our hole's at x minus 3 equals 0, which means x equals 3. We have to find the y coordinate to that. So if I simplify this, you always want to use your most simplest form of this equation. That's 4 over x minus 1. And I'm just going to plug 3 into that. So that's going to be 4 over 3 minus 1, which is 4 over 2, which is 2. So we have a hole here at 3, 2. So then if we go over 3 up 2, there is our hole right there. Okay. And then this is a good example of when you're not going to have an x-intercept. So up top here, 4 cannot equal 0, which means that there is no x-intercept. So if you just have a number in your numerator, you're not going to have an x-intercept because that number will never equal 0. There's no way that you could make 4 equal 0. Okay, without multiplying it by something, but that would mean that there's a variable there. Okay, vertical asymptote, set the numerator or the denominator equal to 0. So that's x minus 1 equals 0, which means that x equals positive 1. So we have a vertical asymptote here at x equals positive 1. So I'm just going to go over to 1 here. And there's that asymptote. And then horizontal asymptote, again, it doesn't matter if we look here or if we look here. If we look here, that's the first degree on top, second degree on bottom. Here, this would be like a 0 with degree on top because there's not an x there, or a first degree on bottom. So the degree of P is less than Q, and that's always the case. I mean, like, it will always be the case that whatever you start with should be the same as the end, because if you cancel something, it cancels top and bottom, so it decreases the degree by the same. But if P is less than Q, look over at our chart, that means we have a horizontal asymptote at y equals 0. That's the easiest horizontal asymptote. It just tells you it. So then our horizontal asymptote's y equals 0, which is going to be right there, which makes sense why we don't have a hole. I mean, we don't have an x-intercept because you can't cross that. Okay. And then for our number line, I'm just going to put 1 on here. There's nothing else I can put on. So if I plugged in 0 to this equation, I end up getting -4. So the left side of this is negative. If I plugged in 2, so the right side of this, I get +4. So it's going to be positive. So this graph looks like that. Okay. Then the domain here, -infinity to -1. Oh my gosh, that should be a positive one. -infinity to +1. +1 to 3, and then 3 to infinity. Those are positives because our asymptote's at 1, not at -1. And then the range, -infinity to 0, 0 to 2, and then 2 to infinity. You don't have to find domain and range on the homeworks. It's just kind of good practice, especially for like getting into calculus and stuff. But any questions on that? Okay, so the homework is a lot like last time's. I'm going to actually post this answer key today because I just want to make sure that you guys are doing it right. And the easiest way to do that is so as you're going through it, you can check the answer key. I just finished it, so I will post it right now. It's in the same place that the other ones are. So if you go to our Canvas page, just go to modules. I posted the first 2 if you haven't seen them yet, but they're just right here. So 12.1, 12.2. I'm going to post 12.3 right here. Okay. The review, I'm going to do a review tomorrow, probably at like 1 o'clock. So if you want to hop on Google Meet, it's going to be kind of similar to what we did today. And then test is on Friday. That is the last thing we are doing this year. Okay. Questions with any of that? All right, if there's no questions, I'm going to stop recording this. I'll stay on for like 10 minutes. If you guys have questions, you can ask your questions. But I'm going to stop recording this.